Welcome to another deep dive. This time, we're going to be taking a look at quantum cognition.
Ah, yes. Now,
Fascinating stuff.
I know some people hear quantum and they immediately think, oh, are you telling me that my brain is like a quantum computer?
Right.
But that's not really what this is about, is it?
It's not really. What's interesting about quantum cognition is that it kind of uses the mathematical tools of quantum mechanics
Okay.
to understand how we think, how our brains work. And sometimes it turns out that classical probability,
Yeah.
the way that we traditionally think about probability, just doesn't really explain it.
Just doesn't quite cut it.
Yeah.
Yeah, and one of the best examples of that is the classic Linda problem.
Right.
So imagine you're told about this woman named Linda, and Linda is outspoken, she's really into social justice, and she's always been passionate about equality.
Okay.
So then the question is it more likely that Linda is a bank teller? Or is it more likely that Linda is a bank teller and active in the feminist movement? It's tempting to say the second one,
Right.
because she just sounds like she would be.
She totally fits the description.
Exactly. But the thing is, with classical probability,
Wow.
the probability of those two things happening together, being a bank teller, A and D being active in the feminist movement, cannot be higher than the probability of just being a bank teller.
Right. And yet people always get this wrong.
Yes.
And it's not just that they're guessing. Like, studies consistently show this.
Yeah,
That people violate this basic principle of probability.
they really do. And it reveals something really interesting about how our minds actually work.
Absolutely. And it's not just some, like, fun brain teaser.
Right?
This actually has some real implications. For example, the sure thing principle.
Oh, yes.
This is a big deal in, rational decision making.
Yeah. It basically says that if you prefer something
Right.
in two different situations, then you should also prefer it when you don't know which situation you're in.
Yeah, that makes sense. Like if I like chocolate ice cream, whether
Yes.
it's sunny or rainy, then I should like chocolate ice cream even if I don't know what the weather is.
Exactly. Exactly. But
Yeah.
it doesn't always work out that way.
It doesn't.
So imagine this. You're offered this gamble, a coin toss.
Okay.
Heads you win $200, tails you lose $100. Most people would take that gamble.
Yeah, sounds good to me.
All right. Now imagine you've played one round of this game,
Mm-hmm.
but you don't know the outcome yet.
Okay.
Would you be willing to play a second round with those same stakes?
Well, yeah. I mean, the odds are the same whether I know what happened the first time or not. So yeah, probably.
Logically, you're absolutely right.
Okay.
But what's interesting is that people are less likely to play that second round when they don't know the outcome of the first round,
So even though the odds are the same,
even though the odds are the same.
there's something about not knowing that makes people hesitate.
Yes. It's like that lack of knowing creates this uncertainty that classical probability doesn't really account for.
So like our brains don't just operate based on like pure logic and numbers.
Yeah.
There's other things going on there.
It's more nuanced than that.
Yeah,
Like how we feel about the situation.
exactly. And that's kind of where quantum cognition comes in,
Okay.
because it uses the math that describes like the unpredictable world of quantum mechanics
Right.
to try to understand the unpredictable world of, our thoughts of how we think.
So are you saying like our brains are literally doing quantum calculations?
No, not really. It doesn't mean that our brains are quantum computers. It just means that it
Okay.
uses the same math, the same framework
Okay.
to try to model like the way we think. It's a different way of looking at things. So instead of thinking of like our beliefs as these fixed points,
Right.
quantum cognition looks at them as if they're constantly in flux, like waves almost.
So like our mental landscape is like the ocean. That's a great way to think about it. Yeah, with waves of thought like crashing into each other, interacting.
I like that. Okay, so one of the key ideas here is this concept of incompatibility.
Yeah. So just like in quantum mechanics, when you measure one property of a particle, it can affect another property.
Mm-hmm.
It's the same with our thoughts.
Okay.
Certain mental processes
Yeah.
can't be done at the same time
All right.
without influencing each other.
Okay, now I'm starting to see how this ties back to the Linda problem.
Right.
Because we can't really think about bank teller and feminist at the same time without one kind of bleeding into the other in our minds.
Exactly. Exactly. And this also plays out in the real world, too. Remember that study about racial attitudes we talked about?
The one where they asked people, like, do you think white people dislike black people and vice versa?
Yes, exactly that one. And they found that The order of those questions actually really mattered.
Oh, really?
Yeah. The answers they got were totally different depending on which question they asked first.
So it's like asking the first question kind of primed people's thinking.
Exactly. Like it created this context that changed how they responded to the second question.
So it's not that their opinions change, it's just that the act of thinking about one racial group first kind of influenced their thoughts about the other one.
Exactly. It just shows you how much context matters in how we think and make judgments. Our thoughts aren't just like static things.
They're dynamic.
They're dynamic, always evolving.
They're all jumbled up together.
That's right.
So, okay, this is super fascinating. But I'm still a little fuzzy on how this idea of incompatibility and like the whole quantum framework actually helps us understand why we make decisions that seem irrational or how we even form like concepts in the first place.
Right. Well, let's go back to that conjunction fallacy with the Linda problem.
Okay.
One way that quantum cognition models this is by saying that we're not really processing bank teller and feminist through the same lens, so to speak.
Like we're using different filters for each.
Yes.
Yeah.
Exactly. Like we might see bank teller through a filter of, professions.
Yeah.
And feminist through a filter of social activism.
Right. Okay.
And these filters, these different contexts, don't always work well together.
So it's like we're looking at them through different colored glasses almost.
Yeah. That's a great way to put it. And when you combine those different lenses, it can kind of like create these interference patterns.
And that's what leads to those weird judgments.
Exactly. And this idea of filters or lenses also applies to how we categorize things.
Oh, yeah, like the pet fish problem you mentioned earlier.
Yes, exactly. Think about a goldfish.
Okay.
Is it a pet? Is it a fish?
Mm.
It can be both.
It can be both.
And that really messes with our usual ways of thinking about categories.
Our brains don't like that very much.
No. But quantum cognition actually handles this kind of overlap a lot better.
How so?
Well, it uses these concepts like superposition, where a concept can be multiple things at the same time, and entanglement, where different concepts are kind of linked together in these weird ways.
So our brains aren't just like storing information in neat little boxes.
Not at all. It's more like this messy web of interconnected ideas.
And it's all constantly changing and influencing each other.
Exactly. And that's where things get really interesting, because if our thinking is inherently like that, so contextual and dynamic, it really makes you wonder about what it even means to be rational.
Yeah, what does it even mean?
Right.
It's like our brains are playing by a different set of rules.
Maybe they are.
So we've talked about how quantum cognition can kind of explain why we make decisions that, on the surface seem kind of irrational.
Right, right.
But what about those classic paradoxes you mentioned earlier, like the Allais paradox and the Ellsberg paradox? How do those fit in?
Ah, yes, those paradoxes. They're really interesting because they kind of poke holes in our classical ideas about decision-making.
Yeah, like they show that we're not always these perfectly logical beings who just want to maximize our gains, right?
Exactly. And quantum cognition offers a really unique perspective on why that might be.
Okay, I'm intrigued. Let's break these down one by one. First up, the Allais paradox.
All right.
Remind me, what's the gist of that one again?
Well, the Allais paradox basically presents people with these choices involving lotteries. And in these lotteries, one option is like a sure thing, a guaranteed outcome.
Okay.
But the other option involves some risk.
Mm.
But there's also a chance of getting a much bigger reward.
So, like, logically, we should always go for the option with the bigger potential payoff,
Well,
right?
in theory, yes. If we were just these, like, purely rational agents always trying to maximize our expected value,
Yeah.
that's exactly what we would do.
But
that's not really how people behave in the real world.
we don't.
Nope. They often choose the safe option, the guaranteed one,
Yeah.
even if it means missing out on a potentially bigger prize.
Can you give me, like, an actual example?
Sure. Imagine you have two options.
Okay.
Option A, you have a 100% chance of winning $1 million.
Sweet. $1 million.
Option B, there's an 89% chance of winning $1 million.
Okay. Still good.
A 1% chance of getting nothing, and a 10% chance of winning $5 million.
Oh, okay. That's a tough one. So option A is a sure thing, but option B, there's that chance of getting that huge $5 million payout.
Exactly. And if you crunch the numbers, option B actually has a slightly higher expected value.
Right.
But what happens is most people actually choose option A, that guaranteed million.
Yeah, I can see why. $1 million is still, like, a lot of money. and it's guaranteed. I don't have to risk getting nothing.
Exactly. People are often willing to give up a little bit of potential gain for that feeling of certainty.
It's like choosing the familiar path over venturing into the unknown, even though the unknown might have, like, hidden treasure.
That's a really good way to put it, and that's where quantum cognition comes in. It suggests that this tendency to choose the safe option, it's not necessarily irrational. It might actually reflect how our brains deal with uncertainty at a very fundamental level. Remember that idea incompatibility we talked about earlier?
Yeah, like how certain mental processes can't happen at the same time without messing with each other.
Right. And what quantum models suggest is that our evaluation of risk and our desire for certainty, those might be two incompatible processes in our brains.
So when we're faced with a choice that involves both risk and potential gains, those two processes are kind of clashing with each other.
Exactly. It's like a mental tug-of-war going on up there.
So it's not that we're bad at math or we don't understand probabilities. It's that our emotions and feelings about uncertainty get all tangled up in the process.
Right. And that brings us to the Ellsberg paradox.
Oh, yeah, that one was trippy. That one's all about ambiguity aversion.
Yeah, basically it's the idea that people prefer known risks to unknown risks, even when the probabilities could be the same. It's like that discomfort we feel when we just don't have all the information.
It's like opening a present from someone you don't know that well.
Oh, yeah.
Like, you know it could be something amazing, but not knowing what's inside, it kind of makes you nervous.
Yeah, that's a perfect analogy. And the Ellsberg paradox really captures that feeling. Imagine you've got this urn with 90 balls in it.
Right.
You know 30 of them are red.
Okay.
The other 60 are either black or yellow, but you don't know the exact split.
So there's that mystery element, right? Like how many are black, how many are yellow?
Exactly. Now you've got two choices. Choice one, you bet on red. You draw a red ball, you win $100. Choice two, you bet on black. Draw a black ball, you win $100.
Okay. So with choice one, I know I've got a 1 in 3 chance of winning. But with choice two, it's fuzzier, right?
Right.
Because I don't know how many black balls there are.
Exactly. And that's where the ambiguity aversion comes in. Most people will choose to bet on red.
Even though, like, the odds of winning by betting on black could be the same or even better?
Exactly. But that lack of knowledge, that ambiguity, it creates this, discomfort that just kind of pushes us towards the known option.
It's like our brains are saying, like, okay, I'll take my chances with the devil I know rather than deal with this uncertainty.
That's a great way to put it. And this is where that quantum framework comes in. It suggests that this ambiguity aversion might actually be a result of how our brains process information in this fundamentally probabilistic way.
You mean like how quantum systems work?
Exactly. Quantum cognition proposes that when we're faced with these, ambiguous choices, our minds don't just calculate probabilities based on the info we have. They create this superposition of possibilities.
Disposition, like holding all the potential outcomes in mind at once.
Yes. Just like a quantum particle can exist in multiple states at the same time.
Whoa. Okay, my brain is officially bending, so we're not just being irrational or overly cautious. Our brains are using a totally different type of logic, a quantum logic, to navigate this uncertainty.
It's possible. Quantum cognition challenges us to reconsider what we even mean by rational. And it opens up all these new possibilities for understanding the complexities of human thought.
Okay, so we've covered how quantum cognition can kind of shed some light on why we make decisions that seem, well, irrational. But I'm thinking about the big picture here.
Yeah.
If our thinking is really using these quantum principles, what does that actually mean for us? Like, are we just doomed to be these walk-in paradoxes forever?
Well, that's a really interesting question, and it gets to the core of what makes quantum cognition so compelling. I mean, it really challenges us to rethink what we even consider rational. We tend to think of logic as this rigid, rule-based system, but what if our minds are actually working with a different kind of logic altogether?
Okay.
One that's more fluid, more contextual, one that actually embraces uncertainty and even contradictions.
Yeah, I mean, that actually makes a lot of sense when you think about it. The world is full of uncertainty. Maybe trying to squeeze everything into these neat little logical boxes is where we go wrong.
Right. And that's where quantum cognition offers this really powerful shift in perspective. It's not about throwing logic out the window, but more about expanding our definition of it. So instead of seeing those inconsistencies, those paradoxes, as glitches, we can start to understand them as features.
So?
Signs that our minds are capable of holding multiple perspectives at once,
Right.
embracing ambiguity.
And even using that contradictory information when we're making decisions.
Exactly. So it's not about being perfectly rational in that classical sense,
Yeah.
but maybe, like you said, being quantumly
You
rational.
like that?
Yeah.
Quantumly rational. So it's about recognizing that context matters, that uncertainty is just part of the deal,
Yeah.
and that our different mental processes are constantly interacting and influencing each other.
It's about seeing the world and our place in it through a probabilistic lens.
Embracing the fuzziness, the unknown.
Exactly.
Wow, this has been an amazing journey.
It has.
We've gone from, like, questioning our own sanity with the Linda problem to exploring how quantum mechanics might actually be the key to unlocking the mysteries of the human mind. Who would have thought?
It's pretty incredible, and we've really only just scratched the surface. What's exciting is that researchers are taking these quantum principles and applying them to all sorts of cognitive phenomena.
Like what are some other areas where this stuff is making a difference?
Well, for one, there's concept formation and categorization. Like, how do we create categories in the first place? How do we deal with those overlaps, like the petfish problem? Quantum models are offering new ways of understanding just how fluid those processes are, how much context really matters.
So it's not just about individual decisions, it's
Right.
about how we make sense of the entire world around us.
Exactly. And this has huge implications for how we understand language, how we learn new things, how we solve problems, even how we interact with technology.
Oh, speaking of technology, I've heard that quantum cognition might even be relevant to artificial intelligence, like AI and machine learning. Is there any truth to that?
Absolutely. One of the biggest hurdles in AI is creating systems that can really understand and respond to all the nuances of human language and thought. And as we've seen, those nuances are often rooted in context, uncertainty, those messy, quantum-like processes.
So we might be on the verge of a whole new era of AI
Yeah.
powered by quantum mechanics. It's mind-blowing.
It really is. And it goes to show that quantum cognition is more than just some, like, abstract theory. It has the potential to revolutionize how we understand our own minds and drive innovation in fields from psychology to computer science. It's pretty exciting stuff.
It is. Well, I want to thank you so much for taking us on this deep dive into the world of quantum cognition. It's definitely made me question some things, and I've got a lot to ponder.
It's been my pleasure.
Yeah.
And for our listeners, if this has piqued your curiosity, we encourage you to dig deeper into the sources we provided in the show notes. Keep exploring this fascinating world of quantum cognition. Who knows what amazing discoveries are waiting out there?
And that's it for this deep dive. Until next time, keep those minds open and keep on learning.